Hello, I'm David D. Hilster. I am a critical thinker, dissident scientist. I'm here to tell you the truth about science, something university professors won't tell you, the mass media won't tell you, and certainly those science evangelists won't tell you. Man, oh, live, I'm so happy to have one of my favorite guys from our organization, right? You're a member of the CMPS, is that correct?
Yes, yeah,
All
that's
right,
correct.
absolutely. And I expect you to be presenting this coming year. I mean, unless you have some reason. We're going to be in Connecticut this year, for those of you who don't know. Well, this year, actually 2008, 18. Oh man, time's flying. 2018, University of Connecticut, where actually the CMPS really had its roots for over a decade there. Dr. Eberly Spencer. She, great scientist. She's in her 90s now. She's a vegetarian. I'm a whole plant-based diet person, and she's lived a long life. But she's got her degree in mathematics from MIT, and she is a wonderful person. And she used to set up those conferences there. And we decided we will go back there this year to sort of get back to our roots. So we're really excited about that. And maybe we can get Jeff Yee, is that pronounced right? Yee?
Yeah, that's correct. Yes.
Yeah, Jeff Yee there and maybe present some of his work because he has two books out now. I got the first book and started reading it. And welcome, Jeff. I appreciate you coming here for the interview.
Yeah, welcome. And since we're recording this on Christmas Eve, I'd like to say Happy Holidays and Merry Christmas to everyone too.
Absolutely. Happy holidays to everybody around the world. I do check the channel. Got, approaching 300 on our subscribers, and man, they're all around the world. It is quite amazing because you get all the statistics, and that's really great to see. In fact, critical thinkers are really spread out all over the universe. And tell me a little bit about your background before we start and talk about your book.
Yeah, sure. Well, I work in the electronics industry at a company called ZTE. My title is VP of Product Marketing and Strategy. So I know the electromagnetic, wave, properties and physics quite well. I'm also a visiting professor at the South China Normal University, where I contribute to as best I can in the area of physics, especially related to subatomic particles.
Wow, that is pretty impressive. So what are you doing in the dissident world?
Well, I think the foundation of science has always been to, challenge the status quo, and when we get to subatomic level, I think this is something that, really does need to challenge the norms. Because I think, in my opinion, we've had, a little more than a century of explanations to me that are very confusing. Hidden dimensions and parallel universes, and the electron can be anywhere and everywhere until you look for it. To me, is not a satisfying answer, and it's really about trying to find the truth and really understanding our universe well.
Yeah, I mean, I am with you. So are you familiar with Dr. Alexander Unziker?
No, so I'm sorry, I'm not.
Oh yeah, well then you need to read his book. I'm actually going to interview him. He wrote The Higgs Fake, and
Hmm.
basically he is on a rampage in Europe, and he has succeeded in actually talking to particle physicists. And when you listen to these guys, it sounds like you'd probably agree. There's a lot of mumbo jumbo going on there. There's a lot of particles and things that just, I mean, the physicality of these things has really gone, I think, beyond really, I think, any kind of logical system. But regardless, he has said, we need to go back to about the 1930s and start over. I know you talk about the neutrino and all that's about the same time frame. And
Hmm.
when you go beyond that to the quarks and the Higgs boson and that, he's actually a physicist, a German physicist and a doctor. And he is out there fighting, saying, look, we need to look at the system. We have to look at other ideas because these ideas don't seem to be very, how do you say, as a system, they have a lot to be desired. And that's one of the areas you are working in, the particle physics and the subatomic particles. Tell me a little bit, how did you get started in this area in writing your own, start to look at the subatomic world? How did you get in that?
Yeah, well, actually, that's a really funny story. So, a little more than a decade ago, probably around 2005 timeframe, I was sitting down to write a book at that time, which was a fiction book. Really had nothing to do with what I'm writing now, and I was writing fiction on time travel, right? And I wanted to come up with a realistic, time machine for that novel. And through all the the research, the Michio Kaku books and Brian Greene books and everything I could get my hands on, it was really about string theory at that time. And there was just this gut feel that I had, which is, this is kind of strange. It's how can there be 10 or 11 different dimensions, to make all of this work? And so, as I finished up that novel and I went back to, work, trying to come up with answers to my own questions. It was really just personal at that time. I wanted something that felt satisfying to me to understand how all this works. And I looked at a lot of different things, but I came across the works of two individuals in particular, and there's a third that I eventually ran across. But one was Dr. Milo Wolf, and the other is Gabriel Lafreniere. And both had studied the wave properties of the electron, and we're trying to make sense of how the electron and how forces and how all particles interact, but based on waves, which we already know. I mean, I work in the electronic industry. I work on electromagnetic waves, right? We all know that photons have wave properties, and everyone in physics also knows that particles have wave properties as well. But yet there's nothing in modern physics, at least, that says there's a material to carry these waves, right? Because the aether has been disregarded in physics. And so to me, I think that's the root. You were talking about 1930 as maybe having to go back to the root. To me, I think we have to go back to 1887, which is the infamous Michelson-Morley experiment that discarded the aether. That's, I think, the point at which physics had problems. But anyway, so to answer your question is really about my story, then how I got into this. So I took the works of say, three of the physicists that I mentioned to you, plus more, and I put that into a book in 2012 titled "The Particles of the Universe." And that book was really a call to action to renew a science based on the aether. That we should probably have multiple different paths that we go down as we explore science, but don't discount one. And even though we know photons and particles have waves, discard the aether as being the medium to carry those waves. It doesn't make sense to me. It's like trying to explain an ocean that has waves without the ocean carrying water. So the original book was written as a way to kind of build up a science based on an aether, and I call it a hypothesis because there was a lot in there that was unproven. But 5 years later, now I've worked with a lot of colleagues, gotten a lot of responses, and personally I wrote a handful of technical papers, some of which I co-authored. And my latest book, The Particles of the Universe 2, is really a follow-up 5 years later from that call to action on the aether, with what I believe is a proof for a lot of different points. So I hope that answers your question how I got to this point.
Oh, no, that's very good, actually. And there's some interesting things here. It's interesting you mentioned Milo Wolf because in 2010, our organization at that time was called the MPA. He was one of the 3 recipients of the Sagnac Award, which is basically our Nobel Prize for people working outside the mainstream. I mean, people may laugh at it, but in reality, I think in the long run, these actually could be more valuable than the real Nobel Prizes, which a lot of times goes to a lot of work that's, in my opinion, suspicious. But he was along with 2 other people, and their average age was in their 90s. And the reason we do this and continue to do this is to try to recognize these people that people don't really know about, right? I mean, Milo Wolf is, you mentioned Gabrielle, also, I can't remember the last name. These are people that we outside the mainstream have a somewhat of additional people, I guess you could say, that we put on a list of people we consider important scientists, right?
Yeah, absolutely.
And you also mentioned, of course, you were talking about ether. And so, as my listeners know, I talk about that basically 4 models that people are working on these days. The particle models, like my father and I are, ether model, which are actually the most popular. There's also lattice type models, and a couple of people I know work on those, and there's what they call action at a distance models. So you are in the ether camp, is that correct? Is that something that you fell into? How did you get into that?
Yeah, oh, definitely the ether camp. I fell into it because we need to logically explain how a particle can contain waves, how a photon can contain waves. And so I believe in the ether. I believe that there needs to be a medium to be able to carry these waves. But more importantly, in my latest works, that the proof I think is in what would be a density property. The forces and energy of particles, of photons, has been modeled, and it requires the new equations require a density property. The density implies that there is a medium, that there is a material that carries these waves. So to me, that's the proof of an ether.
Okay, okay, that's fair enough. I think that the other thing too, I do want to say, and it's sort of, I guess it's more common with our amongst the CNPS scientists. But I was talking to somebody who was looking to interview myself, and they're much more mainstream, and they were mentioning about ether or not ether. And of course, if you're in the mainstream, ether is sort of a something dead, it's something proven wrong already, why would you go back to it? There's so many problems, blah, 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 which is, of course, those are generalizations, what people say, it's not necessarily true. But one of the things that was interesting, he said, the person asked me, well, are you an etherist? I said, I'm not, but a lot of my friends are, and they have some really great models. And he was totally shocked by that. The idea that you could, and I think you have that kind of same philosophy, is the idea that you could have actually numerous types of models that can be quite different. People working on these, it just doesn't seem to fit science. And we got into this long argument about how is it that we can have yourself, for instance, a person who's etherist, and myself, a person who's particle, where we have waves of particles, not particle waves in particles. But that's something that he just didn't understand. And I think that is one of the things I want to, I'm sort of going off a little bit for my subscribers, is one of the things is you're going to notice that we in the CMPS actually have many different types of models, many disagreements. I think the neutrino doesn't exist. I don't think it's going to hurt the model that you're working on, because if it's ether, it's an ether particle. It doesn't necessarily have to be neutrino. But people get really shocked that you and I sit and talk to each other, and I have a totally different model from you, and that this can be a great conversation. In fact, we help each other. We have people who are, I help each other. We help people who are etherists. My father gave a talk that says, hey, that fits into the ether theory as well, our models. Is that something that you feel comfortable with, or how do you feel about that? I know that's very different from the way the mainstream people think. They think there's only one model, one idea, but what's your feelings about that?
Well, I think it's a common understanding of people that want the truth. And
Mm,
we all want to know the truth for different reasons. I
right.
think, personally, I just like to know how things work.
Mhm.
But the future generations, I believe, are dependent on this. Unless we really understand, the fundamentals of physics and particles, I believe we're not going to truly ever understand energy. And energy is required for everything that we do, that we are. We eat energy, that we use, for transportation. Everything in our lives are dependent on energy. And my firm belief is, until we understand, the fundamental particles within the universe, that we're never going to have these answers, and the answers are critical to future generations. That was actually the premise of my first book. And then I took the time, along with some colleagues, to work out, the details to try to prove these points. So the answer to your question is yes. I fully support the works of others, anyone that's open-minded, because we all collectively are trying to seek the truth.
Yeah, absolutely. And one of the things I try to do, because I'm a linguist by trade, my area is supercomputers and human language, but I always look at what people try to mean, what they mean by words. And one of the things I've tried to distinguish are what I call critical thinkers from intellectuals. And what I found is that intellectuals, the way I put that, are intellectuals are mostly interested in showing they're smart. Put your Einstein t-shirt on, talk about the latest stuff you read. But deep down inside, they're not really searching for truth. And I think that's one of the things what I call critical thinkers do. I mean, I give the right to look at everything. If someone comes up with some really crazy idea, many times, I look forward to those because in those ideas, in that way of breaking the mold, just breaking out of it, you can get things for your own work. But being a critical thinker, you're absolutely right. We're all searching for what the truth is, and I think we're at a critical junction as well. That we're at a place where a paradigm shift's going to happen because we've pretty much hit the dead ends in numbers of directions. But before, I don't want to get off on that because we could discuss that all day. Because I'm here to talk about your book. Tell me a little bit. I got your books are available online. I got your one book, your first book on Kindle online, correct? You can get that. I don't know, it was 99 cents or something like that, so it's pretty darn cheap. And tell me, let's talk about that first book. I'll put a link down below so everybody can take a look. Tell me, it says a new view of the universe. I know we're going to talk about your second book, but tell me a little bit. It talks about the neutrino, the electron, the atom, how it explains matter, forces time. What do we do next? Just briefly tell me a little bit about the first book.
Yeah, the first book really was a summary of some of the works of a few physicists that I mentioned at the top of our conversation. Notably Wolf, Lafreniere, and the third one would be Xavier Borg. So I was trying to summarize what they put together, plus I added a little bit into a hypothesis that was complete, where it builds a logical structure from the smallest unit, which Dr. Milo Wolf called a wave center, and then how we can build other particles and how those particles can respond to wave amplitude, which is the cause of all forces. And so, some people call it a theory of everything. I'm cautious to use that term, but it does encapsulate, everything about particles and forces, which is why it can be called a TOE, a theory of everything. But it's a very different look when you start with a fundamental particle that Wolf calls a wave center and you build upon that. But then that was really a hypothesis. Wolf and Lafreniere had worked out the wave structure of the electron, but it left many other particles to have to do. So in the last 5 years, since putting together that book, worked with the colleagues on defining a new structure that would be very much analogous to the methodology that was used for the periodic table of elements, right? And in that case, it was various different elements, now 118 different elements in the periodic table that eventually were simplified to atoms that consist of nothing more than just protons, right? I know it's more than protons, neutrons, and electrons, but it's the proton count specifically in atomic elements, right? One proton for hydrogen, 2 for helium, 3 for lithium, et cetera, et cetera. So what we did is we put together a chart and a linear algorithm that is very much analogous to the periodic table of elements. We did that for particles, but these are all particles that assemble based on Wolf's previous explanation of wave centers. Anyway, the point is that what we were able to linearize everything from the neutrino to the Higgs boson, and that chart looks very similar to a chart developed for atomic mass versus atomic number. And therefore, it not only can predict new particles, but more importantly, I think it shows that particles truly can be an assembly of wave centers, very similar to atomic elements being an assembly of different protons. We took that work. Sorry, this might be a long answer to your question.
No, keep going. You're here.
We took that work plus a lot more, and then assembled it into the Particles of the Universe 2. So I like to think of the second book in the series, or the sequel, as being the proof to the original hypothesis that was put together in 2012.
So you take all the particles that mainstream from quarks all the way down, is that correct?
Yeah, and you were mentioning the neutrino earlier. It gets all the way down to the neutrino as being the smallest and lightest particle, and it ranges to the high end of things being the Higgs.
Yeah, I did notice. Oh, did we lose you there? Are you still there?
I am here. I can hear
Okay,
you.
okay, all right. You that's all in your second book, and how can people get your second book?
The second book is available on Amazon. And actually, so you were mentioning the price point earlier. I'd like to address that too. Again, going back to your earlier question, we all seek the truth. My intention is not to profit from these books. The first one was put out there as 99 cents, as the lowest possible on Amazon. Right? Amazon needs to be able to make money on this, so
Right.
the new book is available on Amazon at $2.99. The only reason why I couldn't make that 99 cents like the previous one is this book includes so many illustrations that for the file size, this is the lowest price point literally that I could make it on Amazon. It's available right now on Amazon for free. I'm able to do a giveaway as a launch promotion. But yeah, I post these books on Amazon at the lowest price that I can because it's about seeking the truth. It's not about making profit.
Sure, sure. Okay, and one of the things with the particle model that you're building, I have a question. With all the different, one of the things that is bothersome to people like myself and Dr. Alexander Unziger are all the attributes. Basically, he says that the particle physics has turned into a bunch of arbitrary packages with arbitrary attributes. How do you deal with that? What makes your organization different from that? So you don't get iso spin, half spin, upness, downness. Is that something you just assume is correct, and then you use your particle model to explain that, or can you give us insight into that sort of mapping?
Yeah, no, it's everything becomes simplified instead of 19 different values in a standard model equation that can be tweaked here and there depending on what flies out of the next particle accelerator experiment. It's been simplified to four universal properties. There's a fifth in the equation that's specific to the electron, but literally, four things that are based on wave properties. Wavelength, a wave speed, an amplitude, and the density property, which I mentioned earlier, is related to a medium that carries waves, ether. So it's a simplified version of it. And then things like charge become wave amplitude. The mass becomes a formation of waves. It's standing wave energy. It's really the definition of mass, right? It's stored energy. That energy can be released from standing waves to traveling waves. So from a mathematical standpoint, everything was simplified to those four universal properties of
Mhm.
waves and a fifth for the electron. And then everything else becomes either a formation of these fundamental wave centers that respond to these waves, or a change in wave type. I'll give a couple of examples of that. Mass is one, right? So as you go from traveling waves to reflecting a wave from a center point, as Wolf and Lafreniere described, that standing waves up to a particle's radius where it transitions back to traveling. That's mass. Or a combination of waves leads to constructive wave amplitude. So charge has a fundamental charge for a particle, but yet it can be increased as another. Photons would be a good example of a different type of wave. So there's two fundamental forms, longitudinal waves, and then there's transverse waves. And all these terms, by the way, that I'm mentioning are seen today in sound waves, in water waves. So these are known properties of waves that we can model with math today. Sorry, back to photons. Photons would be a transverse wave, whereas the electric force that governs particle motion is based on longitudinal waves. So the answer to your question is, a lot of what was put together is only based on five mathematical properties, but the rest is just explanations of how all of this is coming together and governing the different forces.
Well, that's super. That definitely is a step in the right direction, especially for ether theories. I have a question. These standing waves on all the wave properties. You're saying that charge. You're talking about, for instance, are all these are these particles the same particle? Are they just all neutrinos? Are they all ether, or are there different levels there?
Yeah, in the book, I was cautious to reuse the term from Wolf, where it's called a wave center. I think the interesting thing to note about it, so all we did is we just assumed that wave, and when I say we, I mean my two colleagues that co-authored this particular paper that linearized the function for particles, but it's just a combination of wave centers. So the interesting thing about it, though, is that when we took a look at the predicted value of one wave center, it turns out to be about 2.39 electron volts. That's within the range of the neutrino. So, at least in one chapter in the book, we hypothesized that the neutrino could be this wave center that Wolf was referring to. But elsewhere in the book, we simply call it wave center because that has yet to be proven.
Mhm. Okay, so, but one of the things, okay, for different particles in a different size, because you have obviously, you guys do also quarks, you said?
Yeah, quarks is a composite particle, though, so it is treated a little bit differently. The known elementary particles are what's really most fascinating because they tend to map to stable numbers that are also seen in atomic elements. So within chemistry, if you're familiar with magic numbers, these are the numbers that tend to be more stable elements. Numbers like 2, 8, 20. 2850. Beyond that, I can't remember the sequence. But anyway, those numbers, interestingly, start to appear also for particles, and they map to what's known as the lepton family of particles. And there are three neutrinos and three electrons that are in this particular family called leptons. But I find it very, very fascinating that a combination of neutrinos, or sorry, I should call them wave centers at 8, the numbers 8 and the number 20 turn out to be the muon neutrino and the tau neutrino. So it's more than just linearizing the particle sequence. We found a lot of similarities to atomic elements when we did so.
Okay, okay. So again, yeah, I'm going to have to. Unfortunately, I didn't get your book yet. I just got your first book and was almost done reading through most of that book. But when you are talking about one of the things I'm not clear still, and I apologize because I didn't get your second book yet, that we're talking about, and that's okay. I'm not too worried about that because I will read it. But one of the questions I have again is these waves you talk about, are they always in the same ether? Is this ether the bottom level of everything?
Yes, it absolutely is. And I think that's one of the very, very interesting points, at least, and I should say I have to do a caveat that at least within our solar system, it can be localized. I won't claim to anything beyond that, but the reason I can say localized to within our solar system is took a lot of calculations from gravity were included, and gravity calculations as far as Pluto have been mapped to these same equations and the five constants that I mentioned earlier. But within that ether, the fundamental wave is a longitudinal wave that is traveling, and I use the word fundamental because it has a default, if you will, wavelength and amplitude, but both of which are known to change. Right? You combine two waves together and they have twice the amplitude. Right? We can see this and model this in modern day physics with waves, sound waves or water waves or any type of waves. So amplitude can change, but yet it has a fundamental value that was calculated. Wavelength can change, but it has a fundamental value that's been calculated. All of these have been in the technical papers that were recently submitted, as well as published in the appendix of the book for the scientist that wants to replicate any of these equations or functions.
And where do you publish your papers in your own book, of course, but where do you publish them other places?
Yeah, the Journal of Physical Mathematics recently published the paper that I've been referring to the most, at least here in this interview, on the particles and the linear function. Other papers I put on VIXRA. Again, I think like you and others, maybe of your listeners, I think we chase the way to be noted and recognized outside of mainstream, physics. So yeah, the 5 technical papers can be found there. But I think the easiest way, since you've already shown, I think at least the cover of the book on Amazon, everything that I've been talking about so far can all be found in the references within that book.
Okay, Particles of the Universe 2, Disrupted.
Yeah. Yeah.
Oh, okay. Okay. Good. Well, that's what's in place of your face today. So so that'll be burned into the audience. And the other question I have is, you mentioned that you are working with some colleagues. Explain to our audience how that works. So you're publishing not by yourself, correct?
Yeah, so credit goes to my colleague, Dr. Yingbo Zhu, and also the department head of the Electronic Paper Institute at South China Normal University, Dr. Gofu Zhou. Together we published this paper on the linearization of particle energies.
Well, I will tell you, just from this conversation, because again, I haven't had the chance yet to read the second book. I mean, it sounds like you would have a very enthusiastic audience at our conference, because there are a lot of people working on ether, a lot of different models. But that's something I think that would be really great to try to for you to also get out and your information toward our dissident group, because we have, right now we have hundreds of pretty active members around the world. So this would be very, very interesting, I think, to them. Now, what you said you've been looking at, how one of the questions people have with models is, how do you show this model to be correct, or to at least be a better model? Because in the end, we can't almost prove almost anything in reality, but we certainly can come up with better models that we think are more useful. You talk about energy on one of the things, which of course is a concept, but it's a very useful concept that we have, which is, I sort of explain it to people, that you can't really hold energy in your hand. You can hold, of course, mass in your hand that can convert to it, but it's mostly, well, how does that convert? Well, we need to have models of that. But you are mentioning a couple of things. One is that you have some maybe experiments or things that you are presenting that would help show that this model to be pretty valid. Can you talk about those things?
Sure. Well, I think first it's worth explaining the scientific model, which certainly I follow, which is first we need to explain something logically. Then almost everything should be modeled by mathematics, and then that allows us, one, to map to previous experiments, but more importantly, to really prove something. You need to provide predictions for a future experiment. So first off, following that, we specifically have laid out everything, logically, what happens to a particle as it assembles into larger particles, how can it, then decay, and forces. But anyway, a very simple logical explanation started with that, then developed a mathematical model behind that, and had to then take the time and painstakingly take the time to match all of that against existing experiments, right? Because and actually, I should add another thing in there, which is then we need to be able to take that mathematical model and derive existing equations, because Einstein's equations for energy are correct. Planck's equations for photon energy are correct, right? So we need to be able to derive those existing equations. But then the most important thing that everyone waits for is, all right, what are you predicting for the future? And there's a handful of things that come out of this. One would be the particles that are likely to fly out of accelerators in new experiments. Now, they should be able to be predicted now that we have a linear function for this. But then again, I think the standard model could also lay the same claim. But more than that, we have a logical explanation for the decay of certain particles, especially the beta decay, protons and neutrons. And there's an experiment that's proposed about the decay times for a free neutron should be longer, longer than 15 minutes if we go further from the sun. And also, and we haven't even touched on atomic orbitals yet, but that's also incorporated into the latest book. There's a lot that has been analyzed for how wave properties affect the orbit of the electron, and we've mapped the known electron orbitals and distances, and I think there can be future ones that are also predicted as well.
Well, that's quite impressive. And you, all this is in your explained in your second book, which is what, almost 300 pages, correct?
Yeah, and just so I don't scare anyone off, the about half of that book is I call it the layman section.
Hmm.
Organized it into two parts so that it should be readable for a general audience. It was kind of written for someone that has at least taken high school chemistry and physics. I think someone that hasn't will probably be challenged even with the first part of the book. But
Right.
I tried as best as I could to write it to that level of audience. But I know that people need more proof than that. So and this is the nice thing about ebooks is that there are convenient hyperlinks throughout the book that jump to a relevant appendix section with all the math, and
Mhm.
then you jump back. So really, the book is intended for even a scientist that needs to be able to reproduce the work that has been done, but I didn't want to be able to distract and take away from a more general audience. So about half the book is layman's terms, and the other half is appendix.
No, that sounds absolutely amazing. Yeah, another question I have, do you have, you said you have graphics in the second book. Who does the graphics? How many graphics? Who did those?
Oh, I know because I did all the graphics myself
Oh,
and
okay.
had to take the time to change all of them for Kindle format. There's 160 different graphics, and that's not even including the
Wow.
images for all the equations that are in there. It makes it a big download. I think it's like a 20 megabyte, ebook now. That's
Sure.
also the reason for the price point. Amazon wouldn't let me do it at 99 cents like the previous one, but anyway, yeah, there's a lot of illustrations in there, and you have to make it more visual and things that people understand. I also included a lot of analogies because just talking about wave centers and standing waves and traveling waves, I think loses a lot of people unless they have a visual of what this looks like. So there's a lot of references back to water waves, and to sound waves and things that people can visualize.
Wow, that's quite amazing. And what program did you use to do your graphics? Computer
Oh, I
program.
use various different ones. PowerPoint for some. I use a program called GIMP on my laptop,
Hmm.
as well for more detailed ones.
Okay. All right. Just a computer person asking another computer question. So, wow, that is amazing. I'm super stoked to read this book. I mean, I've been around ethers for a while. I know Glenn Borkert's work. I'm a infinity person because I look at things all the way up and all the way down. And it looks very fascinating. I know Milo Wolf was really very inspirational to a lot of people, not only yourself. And what I'll do is I'll make sure that I get links to all these things below before I launch this. So those of you watching this, you'll have the links below so you can get a hold of Jeff Yee's book and also his other links that would be interesting. But I think in your book, you said you've got a lot of links. So there's probably the best thing is just to go ahead and splurge on the $2.99 and take a look at that. So my question also got a couple other questions. You say you work in a university. Do you do any teaching in physics or you mentioned that you work with someone, Dr. Uh, is
Yingbo
Yingbo,
Ju.
and he's in
Yep.
southern China. Is that in China?
Yeah. Well, Dr. Yingbo Ju lives in Shenzhen, works in Guangzhou. I am based in California. I live in the San Francisco Bay Area, but
Hmm.
I'm in China once a month. I work, my primary occupation is working in the electronics field at ZTE, and my role as a visiting professor is simply research. It's not a teaching role.
Okay, and so you speak fluently Mandarin or Cantonese or what?
Oh, I wish I did. It would make my life a lot easier.
You-
I do speak I do speak some.
yeah.
but no, I'm not. I'm far from fluent.
Oh, okay. Yeah, yeah. I'm fluent in Portuguese, but and actually we have some Brazilian, pretty brilliant Brazilian people in our group. Dr. Andre Assis is a really good. If you haven't seen that interview I did with him, he works with Ampere and Weber. So very interesting. But this is just totally fascinating to me. I think you are just to be super congratulated on your work. Even though it's extremely different from a lot of the directions I have been myself, I still find the system much better than the current system out there from what you're describing. I think one of the big problems, as Ansgar says, is we've just got too many arbitrary constants and arbitrary all these things. The particles themselves can even be somewhat suspect. And that's my last question to you is, and I've given this to many people in the dissonant world, is that if it turns out, let's just say, it sounds like your system is pretty robust. If it turns out that the particles, even from quarks on down, were not necessarily what's really happening. It sounds like your model isn't going to suffer very much. Is that correct? Or do you
So I want to make sure.
do
I want
you
to make sure I
actually?
understand your question.
Yeah, let me maybe rephrase that. Does your model, because this becomes a circular question. I think this is just something, I think it would be a good one to end on, which is a little bit higher level. It's sort of the circular question. Does your model fit the current model of particles, because the current model of particles obviously has been hammered into sort of symmetrical, hammered into, having somewhat of a, I wouldn't say a logical system, but a system, or is your model, let's say quarks, Higgs bosons turns out to not really be there, but would your model still hold up, or are you really married to it? Is it separate? Does it predict it? What is that relationship there?
The model, the model holds true to the particle masses that are found, not the particle explanations themselves. And
Hmm.
I'll give a good example. The proton. Let's go back in time all the way to a century ago when Niels Bohr developed the model of the atom, right? And
Hmm.
it looked like an electron circling a nucleus, just like a planet orbits the sun,
Right.
right? But eventually proton was found, what, 50 or so years later. In the 1960s, the proton was found to have three quarks. More recently in 2015, CERN announced that the proton has five quarks, a pentaquark structure. All of things that change over time, I think, is the point of my book. If you look at it's good to know the history of physics and when some of these explanations have come about, because if you go back to the Higgs or quarks or a lot of these explanations, right, their masses were found. The masses of quarks were found in the 1960s, but the explanations to me still don't make sense, right? How would that, three quarks and a proton, how would that cause an electron to orbit around a proton,
Hmm.
but yet a proton annihilates with a positron? I mean, it still
Hmm.
doesn't make sense, right? I
Hmm.
mean, they have the
Hmm.
exact same charge. A proton and a positron have the exact same charge. One annihilates and the electron decides to take a orbital path around a proton. But if you look at 2015 when CERN made the pentaquark announcement, well, now it makes more sense, right? Because a pentaquark in that model has four quarks and one antiquark. Now you've got particles of different charges. We can revisit Bohr's original model, then that instead of electron orbiting a nucleus, it's being both repelled and attracted to the same particle. A positron, it just attracts, boom, it annihilates. A proton, it's got this weird dynamic of being attracted and then it gets repelled at certain points. Why? Because there's four quarks and an antiquark in a proton. But again, when we just take a look at explanations, explanations over the last century didn't have all the right information, didn't have this information from the 2015 CERN. So, that's why I think we just need to start from scratch, right? And use the data that we have now and come up with new models. The math is still the same. The particle energies that have been flying out, I mean, that hasn't changed, but our explanations, I believe, need to be changed.
Wow, you and I are on the absolute same page. We're coming from different models, but you and I, man, that was brilliant. I mean, you really put that in a way that I oftentimes have a hard time explaining. My father and I use a particle model, again, very different from what you're doing, but it's been working quite well. And every time we think it's broken, that it can't explain something, but we look at the world the same way. When I look at this stuff, there's an amazing amount of data out there, especially when it comes to subatomic particles, atomic particles, molecules, all of that stuff. And I am absolute agreement of it. We have lots of experiments with lots of measuring, but the explanations for them are really are lacking. They're either just so bizarre that you can tell that they're pretty much lost. They're not really sure, but you can't poo-poo the data out there. I mean, every time I see another picture of an atom, because we've hacked our way down to the basics of the first level of subatomic particles in our model. But the data is out there. It's just phenomenal. I mean, I don't know if my father and I would have a lifetime of the data out there already for us to continue using our model and to have different explanations. You hit it right on the head. That I'm not sure exactly how to word it, but you worded it quite well. I absolutely am in agreement with you. That's quite amazing. So basically, you're doing the same thing. You're using sort of a wave model and an ether model where we're using all particles, but we're in the same boat. I mean, it's not, there's a reason an electron stays around a nucleus of an atom, and it's wonderful to put a plus sign on it and a minus sign and say, magically they attract. And that's one of the reasons I say charge is something very convenient. And my father's an electrical engineer. He's been an electrical engineer all his life, retired. So he's very practical, an engineering kind of mind. But there's something that when you really want to look for truth, what is really happening in this physical world, a model like yourself, I think is absolutely, it seems to me, and I haven't read the second book, but I'm really looking forward to it. I think it's one of the better ether models out there, and I absolutely congratulate you and your knowledge of everything. So, what are your next steps? You're going to continue writing papers, doing publicity for this book. Well, what's your next steps?
Well, I think, yeah, now I'm in the mode of, call it PR mode instead
Right,
of,
right,
writing mode, because now,
sure,
need to bring attention to this. But on a personal basis, now I flip my attention towards using this for real things, products.
right,
Thankfully, I mean, you mentioned your father was an electrical engineer. I'm in a product environment, right? I work
right.
for a company that, is motivated to find answers for these so that we can build products. And I think it's a very different environment than academia, where we said at the top of the hour that we seek the truth, and it's nice to find open-minded people that are seeking the truth. Unfortunately, I think some are chasing the funding, the funding money.
Oh yeah, absolutely.
I think that's where science can get stuck.
Yeah,
Where you're all following the same model because it's the only path for funding.
yeah.
And I'm going to take a guess that a lot of your listeners, on or viewers of your channel are hopefully also people that are outside of that industry, and maybe the reason why we tend to be more open-minded. But anyway, my answer to your question is, I eventually want to, help to build the products that solve our energy issues, and I believe that understanding particles, their fundamentals, their energies, and how we tap into that energy is how we can build better products in the future.
Well, I think one of the things that we've been looking at, just to sort of talk about it, and again, we have two people, myself, yourself, who have very, very different models. We're using the same data. We're trying to describe it. In my opinion, our model is better than the standard model. I'm not saying it's the answer, but it's way better. It's way simpler. It doesn't use almost any mathematics at all. And you have a model that's much, much simpler. You don't have, 19 free variables and things like that. And one of the things that is interesting, and besides describing things and giving physicality to things that we didn't know and saying, hey, this is really what's happening there, is to see what perhaps you can get out of it. And one of the things with our model, because it's based on infinity, I'm not a believer in the ultimate particle, is that we live in different levels of the universe, and basically the level below the light level that we call light and the light gravity level, there's a level, and there's another level. Who has an infinite ether theory is Glenn Borkert. He's coming out with his book actually in 2 days. That's infinity. It's going to be really worthwhile looking at too. But one of the things that we're looking at is a couple of things from our model, and that is we can see if it's not easy, but it could be faster than light communication, because at the level we are, light's pretty much a barrier in speed. But if you go the level down below that, you get into c² speed. So that's something that would be very interesting, especially with communication. If it's tough, but that's something to look at. Another one I think all of our models, including your model, could bring about is, hey, when we see all these science fiction films of giant structures, I mean, if we go through the way we build things right now, why can't we have printers that can take, pure forms of, in your case, ether, or in our case, G1 particles, and say, we should be able to build with nucleons, put those together and build atomic structures, the old alchemy kind of thing. That certainly would be an interesting thing to see in any of our models. So I think all those things that we see in science fiction, it should be science. What I've been calling science fiction should be science possible. Something I sort of coined a couple weeks ago, trying to get we're working on our book as well. So I think that's one of the more exciting things. If you're looking for truth, if you're looking for a real model that hopefully will be much closer to the physical model, we should be able to, as Dr. Karazani, my mentor who got me into this, said, he says it's a matter of technology at that point. It's a matter of engineering. And so that's what you're saying, is you'd like to take your model and now see what you can actually do from it. And if it's a better model, we should be able to do things maybe we didn't see how to do those, right?
Absolutely. Yep. That's the plan.
Yeah, that's all. That's all you're planning, That's not a, I'm just
Well,
joking. I'm
I
joking.
didn't want to simplify it, but
No,
I
no.
should say that's a grand vision, maybe not the plan.
Well,
Let's
no,
just call it.
but I will tell you, that's one of the things I'm trying to get excited. The reason I'm doing this channel is because people like yourself should be way up there, way out there. And there's a bunch of other scientists like yourself who are on the forefront. And again, we have different models, but we have different computer languages. We have different human languages. It's not to say that a model like our particle model may be better for doing certain types of engineering and manipulating the universe than a standing wave particle. And a standing wave particle model, or a wave particle, an ether model, could perhaps give us insights on how to do different things. Whether or not one of those turn out to be true or not, that's of course only time will tell. But it's certainly, we need to get people out there. This is really amazing to me. What you're doing, what we're doing, what other people are doing, that's what is going to be seen in the future. I think other people are generating lots of data, but my last question for summing up, and I don't know, it's easy to answer, but do you feel like we are in a time of a paradigm shift in science, that that new directions are going to start emerging, and that eventually it will turn?
I think we have the potential for it. I wish I could say that I believed we were in a time period of paradigm shift. I think we can be. I'd say I think we're in a rut. And
Yeah, absolutely. Yeah.
Funding, will continue to go towards these theories until something else can break free. And I think after a century of, again, I come back to the aether. A century of physicists trying to explain a world without an aether has led to some really confusing explanations and equations in a mathematical model that there's just very few people that can read and understand the current language of the standard model. So But yet, if you look at, energy, it's simple algebraic explanations from Einstein's equals mc squared to Planck's equal hf, or it's simply just based on frequency. The language of the universe, when you look at it mathematically, is simple, is algebraic, and I think it's man that has made it confusing. I think the universe is actually much simpler than we think.
No, absolutely. And I think one of the major factors, like you said, is people need to get the funding and need to go forward. I would only just, the one thing I would say on your explanation that it's ether, let me just maybe bump it up one level. And the way I would explain it is we don't have physicality for almost anything. We talk about the fabric of space-time. We talk about gravity. We talk about light. It's a wave. It's a particle. It's a photon. We are not, if you say, give me this and put it in my hand, they can't. So whether or not it's the ether, whether or not it's particles, whether or not it's even a lattice structure, whatever it could be, because we don't have proof. I think what we don't have right now is a physicality for lots of the stuff. If you look at the diagram for a proton in Wikipedia, you have a circle that's not even shaded, because if they shaded it, it looked like a sphere. They don't even know that. And then inside that circle, they have 3 other circles. They then shade them because I'm an artist, so I like to look at the way people graphics is. They make those circles a little bit shaded, so they resemble spheres. And in between that, they have these little things that look like springs. Now, if you were to come down from another a more intelligent civilization, you can say, well, this is our model. There's nothing physical about that model at all. And the shocking part of it is no one talks about that. That seems to be the 800-pound gorilla. And the average person does. They're going, the kids are saying, oh, is that what it looks like? And people say, it's not important what it looks like. It's the data we have. We don't know now. And I think we're at a point where that's no longer satisfying to people like yourself or myself and a lot of people.
Yeah.
And
Yeah, one of my favorite ones is Einstein's explanation, that gravity warps space-time. Right? His equations are correct. I don't think anyone doubts that. But sometimes you can stare at an equation and have multiple explanations. And the explanation that gravity warps space-time, well, it's kind of strange, right? So what is being warped in that case if there is no ether? And so instead we make up fields. There tends to be a field for this and a field for that. Well, does the universe really have like 6 or 7 different fields?
Yeah, absolutely. I mean, in our model, we have field is just particles going, in all directions. It's a field. So, I mean, again, it's not. I think the way I would say it, it's not necessarily because, like I said, there are different explanations. Not necessarily that we left ether. What we left off the table was this critical thinking that even started with Newton, and that is, these things should be real physical things. You don't have magic going on. These things, magnets have a magnetic field. That's not like a space-time something field. Like you said, fields are one of my touch things that sets me off. I hate it when people just say field, and I say, what's the field made of? How is a field?
Yeah.
Does it
Yes.
work?
Yes.
And we have right now 3 very good explanations, in my opinion, of what those could be. So what's most important is that's why I really do think, I agree we are stuck, but I also agree we're in a shift, because I'm seeing some really good models that are working. Right now I see 2 or 3 models that are doing way better than what I call the non-physical models we have. So listen, we can talk all the time, and I'm going to, we'll go on and on, but I will tell you this. I want to absolutely congratulate you on your work. It is stellar work. I'm a big fan of yours now, having talked with you. I look absolutely forward, and that's what I'm going to do right away, is download your book. I will do a review of it. I will say I'm one of those people that I admire models. I don't care if it's different or even conflicts with some of the things I see, or what. I don't care, because even if it's not my truths based on some things that I don't believe are true. For instance, I don't believe the neutrino exists, but the model that you put together, I don't think it doesn't even matter. I want to just congratulate you on that, and I will definitely be doing a book review of your book on our channel. but I will tell you, I already like it. I already like what, just talking with you. I really do hope that if you have a chance to present this work to our group, I think you're going to find some people who would really, really like it. Maybe even some people who would actually start working with you. That's one of the great things about our group. So that's something you should, think about. But thank you so much, and greatly appreciate your time. And please, send me your links so I can get those down below, and those people seeing this will see those down there. But thank you so much again.
Yeah, great to talk to you today, and to your viewers. Again, wish you happy holidays.
Yeah, happy holidays to everybody. And like I said, don't take my word for it. Don't take Jeff's word for it. Be a critical thinker. Stay critical. Stay thinking. I'm Dave D. Hilster. I am your science therapist. I'm here to try to get you guys to be critical thinkers and Jeff Yee is right out there. Definitely somebody you want to read, and read that book for $2.99. Come on, folks. It's free. Thanks so much. Ciao for now. Hey, this is Dave D. Hilster. Be sure to check out the other YouTube channels of the critical thinkers. My father, the particle guru, he's got some great videos there where he talks about why you don't need, for instance, dark matter. And we have the king of special relativity, the critical thinker, the guy, and that's the Nick of Time. You want to check him out right here? You can see him right there. Click on them, subscribe to them. You won't regret it. These guys are great, and they will make you think.